this video, we are going to cover volatile memory, hybrid memory, and lastly, non-volatile memory. Firstly, volatile memory is a computer memory that requires power to maintain the stored information or content. Failure to provide power would result in stored information being lost for good. An example of volatile memory is random access memory. Random access memory can be further categorized into dynamic RAM, static RAM, and non-volatile RAM. So what is dynamic RAM? A dynamic RAM do not retain their state for a long period. Its contents must be periodically refreshed. DRAMs are also volatile memories because their contents are lost when power is interrupted. An example of DRAM being used is in the personal computer's main memory. DRAMs are simpler for higher density and low cost, but its drawback is that the access times are longer. Another type of RAM is static RAM. Static RAM needs continuous power for the cell to retain its state. SRAM are said to be volatile memories because their contents are lost when power is interrupted. SRAM can be accessed very quickly, but the downside is that they are expensive. SRAM are used in applications where speed is of critical concern such as processor register files and caches. The difference between SRAM and DRAM is that DRAM is a successor to SRAM. Memory designers reduced the number of elements per bit and eliminated differential bit lines to save chip area to create DRAM. As a result, DRAM is less expensive to produce than SRAM. Having said that, SRAM retains some advantages over DRAM. SRAM does not need to be refreshed because it operates on the principle of switching the current flow in one of two directions rather than holding a charge in place within a storage cell. Also, SRAM is generally used for cache memory, which can be accessed more quickly than DRAM. Lastly, SRAM is capable of byte-level reads and writes and is faster than DRAM, in which DRAM writes data at the byte level and reads at the multiple byte page level. Power differences vary based on whether the system is in active or sleep mode. DRAM requires less power than SRAM in an active state, but SRAM consumes considerably less power than DRAM does when in sleep mode. Next, we'll be talking about non-volatile memory. It's a type of computer memory that can retain information without continuous power supply. NVM is typically used for secondary storages or long-term persistent storages. An example of NVM is read-only memory. ROM can be further categorized into mass ROM, programmable ROM, and erasable ROM. So what is mass ROM? Mass ROM is also referred to as a ROM chip. Its contents are programmed by the integrated circuit manufacturer rather than by the user. Regions of the chips are masked off during the process of photolithography. We will cover the basics of photolithography at the very end of our videos. In mass ROM, its contents are unable to be deleted nor it can be overwritten by the user via program commands, which gives rise to both pros and cons. Its advantages because it discourages hackers from modifying the program code. That being said, mass ROM disallows us to reprogram its content. Another type of ROM is programmable ROM. User purchases PROM in unprogrammed state. To write data into PROM, a special device known as device programmer is used. What it does is that it writes data one word at a time by applying an electrical charge to the input pins of the chip. Hence, users cannot change the content after programming it. To change the content, user needs to discard it and rewrite on a new PROM. Thus, this makes PROM also known as a one-time programmable device. In addition, erasable PROM is also a type of ROM. It is programmed exactly the same manner as PROM, but the difference is that EEPROM can reprogram. To reprogram an EEPROM, all we need to do is expose it to a strong source of ultraviolet light. Lastly, another type of memory system is hybrid memory. Hybrid memory can be further categorized into non-volatile RAM, electrically erasable PROM, and flash. So what is NVRAM? A NVRAM can retain information even though power is turned off. One type of NVRAM is SRAM that is made non-volatile by connecting with a constant power source such as battery. Because of this, NVRAM that is made from SRAM needs available power supply. Another type of NVRAM uses EEPROM circuit chips to save its information when power is turned off. In this case, NVRAM is composed of a combination of SRAM and EEPROM chips incorporated into a single semiconductor die. Benefits of an NVRAM is that it provides superior performance over other NVM products. It serves applications that require high-speed read or write operations with non-volatile memory such as parallel processing controllers for LANs and anti-lock braking systems. Also, NVRAM chips do not require much power and backup can be guaranteed for up to 10 years. Another type of hybrid memory is electrically erasable PROM. Internally, they are similar to EPROMs, but the erase operation is accomplished electrically rather than by exposure to light. The primary trade-off for this improved functionality is higher cost. Lastly, flash memory is another type of hybrid memory. Flash memory combines the best features of the memory devices described thus far. Flash memory devices are high density, low cost, non-volatile, fast to read but not to write, and electrically reprogrammed. These advantages are overwhelming, and as a direct result, the use of flash memory has increased dramatically in embedded systems. From a software viewpoint, flash and EEPROM technologies are very similar. The major difference is flash memories can only be erased one sector at a time. How does flash memory erases one sector at a time, you may ask? Well, flash memory can only read to an entire chunk or sector of a memory at a time. This means that if the user wants to change only one byte, flash must also rewrite all the bytes in that sector. That means that flash memory can wear out faster than EEPROM. As mentioned earlier, we will now briefly describe to you the processes of photolithography. Photolithography, also known as UV lithography, is a process used in microfabrication in order to pattern parts of a thin film or the bulk of a substrate. So now we are going to cover the basic processes of photolithography. The first step is photoresist coating. A substrate, an object, onto which the image is transferred or projected, is coated with photoresist, a liquid polymeric material. The photoresist is the material that the image will be transferred to during the photolithography process. The second step is to expose the substrate to UV light. Once the substrate has been coated with photoresist, the substrate is then exposed on an exposure tool. In standard processes, the system shines light through a glass plate which is partially coated with chrome. After exposure, the photoresist that was exposed to light changes chemically on the substrate. And now, for the third step, is development of the substrate. Once exposed, the substrate is then immersed in a developer solution. Developer solutions are typically aqueous and will dissolve away areas of photoresist that were exposed to light. Therefore, after successful development, the photoresist is patterned with the master image that was provided by the user. Lastly, we hard bake the substrate. After development, the substrate is baked in an oven or hot plate at temperatures between 100 and 120 degrees Celsius. This is needed to drive off liquids that may have been absorbed on the substrate and to cross-link the remaining photoresist. So these four steps are the basic steps of photolithography. In a nutshell, we have covered on volatile memory, non-volatile memory, and hybrid memory. In volatile memory, we have covered types of RAM as well as the differences between SRAM and DRAM. In non-volatile memory, we have covered types of ROM as the basic steps of photolithography. Lastly, in hybrid memory, we have covered the types of hybrid memory and how does flash memory erases one sector at one time.